Can you see my sharing clearly without any problems?
No, sir.
Wait. Okay. So today we are going to discuss about statistical quality control, a new topic, and this will be my last topic. So I would like to quickly give a small introduction. So what is statistical quality control? Sorry. So, the operations, especially operations, companies with operations department, when they are producing something, so they apply the statistical quality control. Okay, so to maintain the quality, because quality nowadays plays a major role in the market and in the customer's mindset. So if there is no quality, then customers will not buy the product. Earlier days, the companies or business people, they compete with price. So when they reduced the price, the demand increased. So the competitions were based on price. But nowadays, because there are so many competitors, so they cannot use the price as the weapon. So the weapon is quality. So by using their quality, by maintaining and becoming excellence in quality, so they are competing. So quality plays a major role. So how to measure the quality, or how to ensure they are producing a quality product? If you are, say for example, say you are producing a okay, you are producing a mineral water, right? Mineral water plant you are having, so you are producing mineral water bottles. So each mineral water bottle must have 1 liter, right? If it is 1 liter bottle, it must have 1 liter. So how to ensure all the mineral water bottles have 1 liter capacity? Sometimes it may increase or it may decrease, right? So recently I bought a 19 liter mineral water, big bottle. About 25% of water was not there. So I asked the shop owner, all the other bottles are fully filled, but why only this bottle 25% is missing? Then the owner told that is company's error. He does not know anything because it is sealed bottle, so nobody can take the water out. So sealed, but 25% of the water was missing. So that was because of manufacturing plant error, right? The particular machine's error. So likewise, when you are producing something, you have to ensure that there are no errors in the production, right? There are no quality problems. So to ensure that, we have to apply statistical quality control methods, right? So this is a new topic nowadays. So as students, you have to know the basic of this. In-depth understanding will be taught in your final year. Okay. So the definition or the description of it says, statistical quality control is the use of statistical methods in the monitoring and maintaining the quality. You have to monitor the quality, right? And you have to maintain the quality. If there are any errors, you have to remove those problems of productions or services. So it can be applied in production sector or service sector also. So that is the main idea of statistical quality control. Right. So this concept was pioneered by Walter Shewhart, right, at Bell Laboratories. It was there in 1920s. This concept was raised in 1920s. So this person, Shewhart, developed a control chart in 1924. So today I will discuss about control chart. So it is a powerful tool to monitor the quality. So that control chart was developed by this person, Short. Right. So he consulted with Colonel Leslie Simon in the application of control charts, right, to munitions manufacture. Munitions. So you know what is munitions? So I have a picture that military weapons, right? So in 1924, that US developed military weapons in a massive amount. So this person contacted that colonel about applying his concept into this munitions manufacture. Right, that was in 1924. So it was a big success because when they are producing military weapons, there cannot be any errors. Small error will give big impact. Yesterday we discussed about butterfly effect, right? A small mistake will create a big mistake somewhere. So especially in terms of military weapons, when they are going to war, they have to be 100% ensure the quality of their weapons, right? That's why he contacted the colonel about applying this concept to his production process. It was in 1934. That became success. Then again, another person, pioneer of operations management, Edwards Deming, invited this person, Shewhart, to speak, to give a lecture, guest lecture at the graduate school of US Department of Agriculture. So he went there and he gave a very good lecture. That lecture later became a book called Statistical Method from the Viewpoint of Quality Control in 1939. Still the book is there in online. That was the first book of this statistical method of quality control. So that was a result of that particular lecture. Then Deming was an important architect. This person, Deming, he was an important architect of the quality control, especially when during the World War II times. So after the World War II, this Deming, the second person, was invited by the Japanese government. You know, the Japan was severely affected by the Second World War. Totally, Japan's economy was totally collapsed. So Japan invited Deming to come to Japan and to advise them how to recreate the economy and manufacturing process. So Deming, who has the concept of this person, Shewhart, knows everything about this statistical quality control. So Deming went to Japan and introduced this concept to Japan, especially for Toyota company and several other companies. And Japan started to apply the statistical quality control mechanisms in their production process. And then Japan achieved their mission in 2000, right? So how the Japan developed within short period of time, one big tool was the statistical quality control that was developed by Shewhart and applied by Deming. So when Deming returned to America, America was a little bit down compared to Japan. So within short period of time, Japan, they learned to use the statistical quality control methods and they developed themselves. Okay, so that was the history. So because Japan used it, then all the other nations started to use automatically, right? Okay. So that was a small history. So you should know the importance of these statistical quality control tools. Okay. So the categories. statistical quality control categories, there are 3 categories. Number 1, descriptive statistics. Already you have studied. Sudha Miss should have taught those things. Descriptive statistics. That is one category. Number 2, statistical process control, SPC. That is what today we are going to discuss. Number 3, acceptance sampling. That is apart from your scope. That I will not discuss. That will be discussed in later years, maybe your final year. Right? Okay. So you will study, management students, you will study a subject called operations management. Similarly, commerce also, you study operations research. So in those subjects, you will study about this further. Okay. So these are the 3 categories. Now we will move to one by one. So descriptive statistics, you know the knowledge of it. So descriptive, the name says describe, right? So these statistics are used to describe the quality characters. Only describe. Describing is the main idea, right? So if I ask you to describe about me, you will describe about me. Who is Dinesh and what he can do, what he lectures, right? How he appears, what is his quality, everything you can describe. That is the first category, description. So now I have a small question to you, because you have studied these things. State some descriptive statistics you have studied so far. I saw your LMS, Sudhamis has uploaded many handouts. So you have studied these things. So you can tell some descriptive statistics you know. You can put those things in chat box also. I cannot see any answers so far. Okay, I will start. All right, one answer came. Mean. Comes 16. Okay, mean. Very good. Then it comes median, mode, standard deviation, range, variance. Right, fantastic, fantastic. Nice, thank you. So these are the descriptive statistics. Frequency, yes. Nice. So you know those things. So no problem. I will not explain here. Skewness, right. So mean, you know, it measures the central tendency. Then range, difference between the highest and the lowest. Standard deviation, that measures the amount of spread or data dispersion. Okay, the spread is measured, that is standard deviation. Okay, so that is descriptive statistics. So you know the formula of mean, and you know what is a mean, average, that you can simply calculate and you can tell. And range also, you know the difference between largest and the smallest. So here the range is 9 minus 3, it is equal to 6. And standard deviation, this is the formula we use to calculate standard deviation. So by applying this formula, you know how to calculate it. So that is okay. I will not discuss about these things. Right. Now we are moving to the second area. That is statistical process control. So it extends the use of descriptive statistics. So Descriptive statistics only you can describe. This is one step further. You can apply descriptive statistics to monitor the quality of the product. Right? So you can apply this to monitor the quality of the product or the process. And these statistical processes control helps to determine the amount of variation. Okay, you can control the variation and determine the amount. And the third one is very important, to make sure the process is in a state of control. So when sometimes in future you will work in manufacturing organizations. So sometimes you may work in production department. So your boss, your supervisor may ask you one question, whether production is controlled, under the control. Then you have to tell yes or no. So that state of control, the third one, if you want to tell yes or no, you should know how to calculate it, right? And you will have several computer softwares, don't worry. Here we are calculating manual mechanisms, but in future you will apply using computers applications, right? Right. So that is the use of the statistical process control. Then there will be a question. Variation in quality. You cannot ensure 100% same products, right? Even if you are producing, say, pen, or you are producing pen, there will be a small difference between one pen and the other pen, right? And even so, if you are manufacturing water bottles of 1 liter, there will be a small difference between two bottles. Maybe the first bottle will have 1 liter, second bottle may have 1.01 liter, small increase, or sometimes 0.99 liter, small decrease. That occurs because no two items are exactly same, or no people are exactly same, or no raw material units are exactly same. There are small differences that you have to accept. Okay, so that right. So that is the first point. Second, okay, that second also I have discussed. So these differences in characters is known as variation. So there will be variation between products. You have to accept it, but you have to measure the amount of variation. That is the question. So then the next question arises: why? Why there are variations? So the last point, the variation may be due to substandard quality of raw material. Maybe the raw materials quality may be low, or carelessness of the machine operator, some errors or mistakes of machine operator, or sometimes fault in machinery. So fault in machinery also possible. Then so likewise there are so many errors. Okay, so these types of variations can be categorized into two main sections. The first one, variation due to chance causes, variations due to assignable causes. So chance, say, I will give you a small example. I have only 2 students. Okay, I have only 2 students. So I am teaching the same way, right? The learning materials and the method of my lecturing, the handouts, I give everything same for those 2 students. But still, one student gets 95 marks and the other one gets 85 marks. So when I analyze the reasons, sometimes it is natural, right? So that means one answer maybe he did not study. He or she did not study like the other person. So that is the assignable causes. The second one. Oh, one student sleeps more hours than the second student. Oh, one student does not have enough concentration. So these are the assignable causes. You know, this is the reason. So you can assign. So in manufacturing organization, you know, there are errors because machine problem. Or people did not work correctly. Absenteeism, right? Or poor raw materials. So you know the reasons. So if you know the reasons, that is called assignable cause. You can assign it to the problem. At the same time, everything will be perfect. Perfect raw material, perfect machines, no any machine mistakes, no any problem with machine operator, good climate, everything is perfect. Still, there may be some problems. So I told you, no, if you produce water bottles, everything will be perfect, but still there will be small changes in the volume. One bottle may have 0.98 liters, one bottle may have 0.99 liter, and one bottle may have 1 liter, 1.01 liter. Okay. So those still there are small errors, but you have to accept it. If you ask any operations manager, they will tell there will be small variation. They will accept. So those are called chance causes. There are chances to have those errors because no one is perfect. Still, there will be small differences. That is called chance causes. So this is variations due to chance causes or common causes. So the variation occurred due to chance, or the variation is not, it is not due to the defect in machine, not because of raw materials, or not because of any other factors. You don't know the reasons. So behave in random manner. Randomly it happens. Okay. So it happens randomly. Negligible. Point number 4 says negligible means you don't need to be worried about it. Don't worry about it. You can neglect it, but inevitable. So you cannot avoid it. It happens. Every day it may happen. You cannot avoid. At the same time, no need to worry about it. It is general common causes in all the factories in all over the world. Right? So if you have these errors, still the process is said to be under the control. Chances errors are happening, but no problem. You don't need to worry about it. Still the process is under the control, right? So you don't need to worry about it. That's the main idea. It happens. But the second type of causes are very big problematic causes. Non-random causes or variation due to assignable cause. Here you know the reason clearly. Difference in the quality of raw material, difference in machines, difference in operators, or difference of time, right? So sometimes in the morning time, production quality will be low compared to evening time. Sometimes in the morning time, production quality will be high compared to evening time. So you know, time is the reason. So these type of problems are assignable, non-random. Therefore, you have to be very careful about these problems. If these problems occur, you have to quickly correct those problems. Stop the production process, correct the problem, or remove or eliminate the problem, then you can start the production process. So these are dangerous. The first category, you don't need to worry about it, but the second category is dangerous. So you have to quickly take actions to stop those things. Right. So this is an example of control chart. So you can see. So you may know about this graph. This graph you may know, right? So this is called normal distribution. You may have studied this in probability. So this is in this graph, this is the central point, right? This is the central point. That is the average. So that's why this line is the average line. This is called central line. Central line, the middle line, average. From this line, there may be variations to the up or to the down. There may be variations. Say these are the samples. So they have received some samples. Because in production process, you cannot examine all the products, right? For example, one garment industry, one garment factory, they may manufacture 5,000 products in one day, 5,000 garments. So can you examine all the 5,000 garments? No, definitely you cannot. So you have to get some sample, say 100 garments or 50 garments, and you will check those garments only. So these red color dots are the samples. So these samples, there are variations, right? So there are some samples have more value, some samples have less value. So this is the variation. But these two blue color lines, this line and these two lines, these are the control limits. This is upper control and this is lower control, right? So within this range, you can see this name. So within this range, that is the variations due to normal causes. Variations due to normal causes, you can accept this. The normally this happens. You don't need to worry about it. But above those range or beyond those range, so this problematic person or problematic product, this is out of control, right? Why? This is beyond the range. So that is variation due to assignable causes. Maybe machine defect, maybe poor raw material, maybe machine operator mistake, maybe time problems, maybe problems among the staff, machine breakdown.
School kaklang. Yoko school. School. Tani elame aratana intati ba. Ukutulete ani school parendu. Ito wate ante poki ba. Iting aru padipela inta siya.
Okay, that was an interruption. Right. So if you have any points above those areas, lines, then it is called assignable cause, problematic causes. You have to remove those causes, right? So this is the idea of normal causes and assignable causes. Okay. One example here they have given the variation. So this variation is expressed in range, not absolute values. Here you can see it is not expressed in absolute values, but in terms of range. They will give a range. So example says the diameter of a pen, the diameter of the pen you use, the diameter of a pen is expected by its manufacturer not a 7 millimeter. On average, it must be 7 millimeter, but plus or minus 0.05. So they are giving a range. A pen must be 7 millimeter of diameter size, but it can go up by 0.05 millimeter, or it can be reduced by 0.05 millimeter. So they don't worry about it. That is the range they are giving. So what is the range? That is, it can vary from 6.95 millimeter to 7.05 millimeter. So within this range, a pen's diameter will be there. So you can see this. I have given you a small example. This is a pen. This is the diameter size, right? So as per the production configuration, it must be 7 millimeter, but it can vary between 6.95 and 7.05. You don't need to worry about it. So they will give a range, right? That you have to take into account. Always variation will be in range, right? So now we are moving to the calculation part. So you know the basic concept of this control chart, right? So these black colored dots are the samples. These black colored dots are the samples that the data will be given to you. Your task, you have to calculate, or you have to find out this upper control limit, and you have to find out this average, and then you have to find out this lower control limit. So these 3 points you have to calculate, or you have to find out. So that is your calculation part. So that is what we are going to do now. I hope you have your exercise copies with you. So we will do those things. Okay. So the control charts, there are 2 types of control charts. One is control chart for variables. So I know you know that I hope you know the difference between variables and attributes. So there are 2 types of control charts. One you can draw for variables. Variables means anything you can measure. For example, length, weight, time. So weight means, say, for example, kilograms. Or length of a pen, length of a say mobile phone. You can measure those things. That is variable. Another control chart is there, control chart for attributes. Attribute means discrete values. You can count. Say people, number of employees. You can count the number of employees. 1 employee, 2 employee, 3. Discrete values. There is no decimal place. You cannot tell 1.1 employee. You cannot tell 10.5 employees. Employees cannot be in decimals. They are discrete values. Number of eggs, egg, right? So you cannot tell 5.6 egg or 10.2 egg. Eggs cannot be in decimals. Or number of shirts, production of shirts. You cannot tell 100.5 shirt. There is no 0.5. There is no decimal for shirts. So for that type of discrete attributes, this control chart for attributes can be drawn. This is control chart for variables. First type, any variable you can measure. Say weight, you can tell 2.5 kilograms. So decimals will be there, can be applied. 2.5 kilograms, 5.5 kilograms. Time, 2.6 hours, 0.3 minutes. Length, right, 6.6 millimeters. So decimals will be there in variables. That's why you are measuring those things. So there are 2 types of control charts. One you can draw for variables, and the other one you can draw for attributes. right? So now we will see one by one. So now we are going to study the first category, control charts for variables, anything that you can measure. So today we will discuss about these two types of control charts for variables. The first one is X bar chart and the second one is R bar chart. So X bar chart, you know what is X bar? What is X bar? The average. So average chart. This is R bar chart, means R means range. So range chart. So average chart and range chart we can discuss today. So first I will move to R bar. Right, I will move to this R bar chart. Then I will come to X bar chart. So R bar chart measures the dispersion. You know, the range. Range means difference between the highest and the lowest. So it measures the dispersion of or variability of a process. So how far there is a spread, right? How far it varies. That is measured by range. So first we are going to draw a control chart for range. So this is the data, an example I am going to do for you. Constructing, first we will do R bar. So this the data is same for everything. The factory produces 50 cylinders, gas cylinders per hour. Samples of 4 cylinders are taken at rundown from the production at every hour. So for 1 hour, 50 cylinders are produced. So they are taking 4 samples, 4 observations for every hour. And they are measuring the diameters of the cylinders. Okay. So the question is, you have to draw X bar and R bar charts to decide whether the production is under the control. So what you want to decide, whether the production is under the control or out of control, right? Whether the quality is there or no, that is the question. So for that, now we are going to use 2 graphs. First, we will do the R chart. So some data they have given, N, that is 4. So N means occurrences. So A2, D3, D4. See, these are some values they have given you. So in exams also, these values will be given to you, right? So you don't need to calculate these values. Don't worry about these things, right? So this is the data. So for sample, say sample 1, sample 2, sample 3, sample 4. You can tell this is the observations. So there are 10 samples, 4 observations. For this first hour, they are getting 4 samples. Second hour, another 4 samples. Third hour, another 4 samples. Likewise, for 10 hours, they are getting 40 samples. Okay, so because in production process, you have to be careful about getting the sample, right? So if the company operates from morning 7 o'clock to evening 7 o'clock, then every hour you have to get sample, because morning may be effective time, evening may be ineffective time. So therefore, it's better every hour you have to get sample. So therefore, in this example, 10 hours, every hour they are getting 4 samples. So this is the sample data. So copy down this data in your exercise book like this. Then I will tell what to do next. So I will give you 2 minutes. So once you have copied this data, put OK in chat box. So you will develop a table like this. So 3 more additional columns. So now we are going to calculate first. So after putting these things, remember, these are the samples, right? The yellow color ones are the sample. We have 10 sample. So every hour is a sample. This is first hour. That is a sample. Second hour is a sample. So we have 10 hours like 10 samples. But for each hour, we have 4 observations. These blue color ones are the observations. For the first hour, we are getting 4 observations, right? In the second hour also, we are getting another 4 observations. So remember those things. So here, 2 values will be used, M and N. M is the sample. M is the number of samples and N is the observation in each sample. So M is number of sample, that is we have 10 sample here. So M is 10. And similarly, N observations in each sample. So how many observations we have? In each sample, we have 4 observations. Therefore, N is 4. So be careful in these numbers. Okay. So now I'm going to calculate. Excuse me. Okay, right. So now first point, we have to calculate the average for each sample, right? So average for each sample. So we have 10 samples. So we have to find out the average of each sample. So first I am going to calculate the total. So total you can calculate by adding these values, that is 230 plus 238 plus 242 plus then again, what is the next answer? 250, right? 230 plus 238 plus 242 plus 250. So likewise, you have to get the total for each sample. So that is simple. You have to get the total. So this is the total values of each sample. So the next you have to find out the average. So now I am going to calculate the average for each sample. So you know there are 4 observations. Therefore, this 960 should be divided by 4. Right, so the average is 240. 960 must be divided by 4. Therefore, you have in that way you have to get the average for all the samples. So quickly get the average for all the samples, then we can continue. Maintain 2 decimals. Maintain 2 decimal places. Then once you have find out the average for each sample, then the next point we have to find out the range. So what is the range for the first one? What is the range for the first sample? Yeah, it is correct. So 20. Then one more question. What is the range of this? What is the range of this sample? Right, thank you. So, okay, now you are clear. So be careful. Range means the highest minus the lowest, right? Range is equal to highest minus lowest value. So you have to apply that. So highest will be anywhere within this first four. The highest is 250 and the lowest is 230. Therefore, it was 20. In this second one, here the highest is 250. The lowest is 225. Right? So remember, it may change. You have to be careful about it. Okay. So now I calculate the ranges to you. Hello? So this is how you have to calculate the ranges also. Right, so now we have calculated the important values. So finally, you have to get the total. So get the total of these two values. So the total 2345.75 and the total of the range is 196. So these two values are very important for us. Okay. So far, are you clear with this? If you have any doubts, you can ask me, or shall I continue? Right. So I told you in the beginning, there are two types of chart. One is X bar chart and the other one is R bar chart. X bar chart, that is to find out the variations in process average. That is the purpose of X bar chart. X bar, you know, average. So that will tell you whether there are any variations in the process average. R bar chart will give you variations in process variability, right? Variations in process variability will be revealed by R bar chart. So among these two bar charts, R bar chart is very important compared to X bar chart. Therefore, we have to first find out the R bar chart, then we have to find out the X bar chart. So now I am going to tell you how to draw the R bar chart. So you have to draw the bar chart. So if you want to draw the R bar chart, you need three values. One is CL, other one is UCL, and the other one is LCL. CL means central limit and UCL is upper control limit. And the LCL means lower control limit. So you have to now find out this CL, UCL and LCL. So once you have found out these values, you can draw the R bar chart. So first we will calculate the central limit, right? So first we will calculate the central limit. So how to calculate central limit? There is a formula. So R bar chart, you can put the heading R bar chart. Under that, number one, you are going to calculate central limit. For that, you have to use this formula. So average of the range is the central limit. So that you can find out. So using this formula, can you put the answer on the chat box? You know this value? Sigma R, you know. M also you know. M I have already given you. M means number of total samples, 10. So what is the value of central limit? Right, exactly. Your answers are correct. So that is, so this is equal to sigma R. We have found out, right? This is sigma R, the total of range. So that is 196. That is 196 divided by M, total sample size, that is 10. We have 10 hour sample. So that is equal to 1.96. This is what? This is the central limit. This is the central limit. So now number two. Number two, we have to calculate upper control limit for bar chart. Yes, thank you for your answers. Your answers are perfect. So upper control limit for R bar chart. So the upper control limit for R bar chart, you can calculate using this formula. This is the formula to calculate the upper control limit. So can you tell me the answer? Sorry for that. I was talking without unmuting. So what I was talking is, you may have a confusion about this D4 and D3 value. Right? D4, D3 values, these are the control values. There is a control chart like D1, D2, D3, D4, D5, D6. There are so many D values. So used in statistical control operations. So there's a chart. So you have to see the chart and you have to get the number. The chart is developed based on sample sizes. So in examinations, we will provide you the chart. So you can see the chart and you can get the numbers. So for example, I can show you the chart. Then you can get the idea. And this is the chart. So there's a chart like this. So we will give a chart to you in exams. So you can see D3, D4 values are here. So D3 values. So you know our N is 4, right? Our samples, observations in each sample is 4. So here you can see for 4, these are the values. When our N is 4, D3 is 0 and D4 is 2.28. So you can use these values. So the same thing was given in the question also, I think. Yeah, here also they have given D3 0 and D4 2.28. Right, so using these, you can calculate now. Yeah, your answers are correct, I think. Lower control is 0, upper control is 44.66. I will check. So upper control limit. So this is equal to D4 value, that is 2.28 into R value. R value, R bar value. So our R bar value, we have calculated that 1.96. Therefore, 1.96. Sorry. This is 19.6, right? 19.6. So that is 19.6. Therefore, the answer will be 2.28 into 19.6, 44.68. Yes, very nice. So better we can have this in 2 decimals, therefore 44.69. Okay. So then lower control value. So that is equal to D3 is 0.00 into R bar 19.6 equal to 0. So lower control is 0. So now we have the 3 values. This is 19.6 and 44.69, 0. So we have now 3 values needed to draw the R bar chart. So how to draw the R bar chart? We have to use these values. The red color one. Using these, we have to plot these values in a bar scatter diagram. Right, we have to plot these values in scatter diagram. So how you can develop a diagram? So I will show you a sample. You can draw that in your exercise book. You know how to draw a diagram like this, one axis, and like this, another axis. So this axis will have this, what do you call it? M. That is your sample size, samples. So sample may be say 1, 2, 3. Likewise, you have how many samples? 10 samples. So you have to draw for 10 samples. I don't have space, so I just give you some example. And here you can see this line must be the y bar, so the y line will be what? Your diameter, your variable. So diameter, say I am putting like 5, 10, 15, 20, 25, 30, 35, 40. Likewise, by using a proper measurement, you can draw the diameter line also. So after you have drawn this, now you have to plot the points. So for example, our sample 1, the range is 20. Our sample 1 range is 20. So we have to plot 20. So sample 1 range is 20. So you have to plot there. A dot or a circle or a streak, whatever. You can plot something. Then sample 2, the range is 24. Sample 2 range is 24. So that you can plot here, 24. That is very difficult for me to draw. It will come here, right? Somewhere here it will come 24. Because this is Excel, difficult to draw those things. Okay, likewise 24. Then number 3, that is 18. So 18 will be here. Right, so that is also difficult for me to draw. So likewise, you have to first draw the scatter diagram. You have to plot all the observations in this graph. That is your first task. All the observations in the graph. So now I will show you a graph quickly by using Excel feature. So simply I can write, this is the graph. This is the scatter plots. Hope now you can see my graph. Okay. So 10 observations, 10 samples, there are 10 points. And this is the bar chart, R bar chart. Excuse me. Okay, right. So this is the R bar chart. Now we have to set our control limits. So we have 3 control limits. So you can see here. The first one is 19.6. So 19.6. So I'm going to draw the 19.6 line. That will come here. So you have to draw the first central line. So that is, you can use any color. So this is the central line. So 19.6 means 20, right? So 20. So that is central line. Okay. Then you have to draw the upper control limit. So upper control limit, that is, we know upper control limit is 44.69. So that is 45. When we round it, it is 45. So that is also, we have to draw that. So this is the upper control limit. So that is UCL. That also we have drawn. And the third one is lower control limit. Lower control limit is 0. In our example, it is 0. Therefore, lower control limit is 0. So that is lower control limit. Okay. So this is how you have to draw an R bar chart. So this is the average central line. It must be 19.6, close to 20. But variations are possible, because I told you there are two types of variations: common reasons, assignable reasons. So based on that, we have drawn our upper control limit. We can tolerate within this limit, and lower control also we can tolerate. So you can see all our dot marks, all our points are within the range. All the points are within the range. So no, there are no any problems. Right? So I hope you understood. All our points are within the range. So there are no any issues. So what is your decision? Finally, you can tell. There are no variations in process variability. There are no variations in process variability. Right? So the first check is okay. So that is R bar chart says no problem. No variations in the process variability. So now we have to check what? The second chart. The second chart is X bar chart. So R bar chart is okay. So now we are going to check the second one, that is the X bar chart. If the R bar chart is problematic one, then total process is out of control. Right? So when you check the R bar chart, if that is wrong or if that is out of the control, if some points are above the line, then you have to stop the process, because that is out of control. You have to stop the process, find out the reasons, remove those reasons, then you have to start the process. But in our example, R bar chart, there is no any problem. All the points are within the limit. Therefore, now we are going to check the second chart, that is X bar chart. So I have you understood up to this point? Put yes or no in the chat box.
ෆෝන් ගැන එහෙම දන්නවද කරන්න කිව්වම දෙයක් වැඩේ ෆයිල් ගන්න එක තමයි
Right. So now I am moving to X bar chart. So now we will move to X bar chart. Right. So for the same 3 points we have to calculate. Right, for the same 3 points we have to calculate. Central limit, upper control limit, and lower control limit. So central limit, that is the average of all the individual averages, right? Average of all the sample averages, that is the central limit. So you can use this formula for that. It's called X double bar. It's called X double bar. So you can see, I will zoom this. This is X double bar. There are 2 bars. Why double bar is already we have X bar. In our data, we have this data. This is X bar data. Right? This is X bar. So already we have calculated the average. So again, we have to calculate the average of these averages. So second time we are calculating the average. Therefore, it's called X double bar. So using this formula, can you tell me the answer? What is the central line? Yes, your answers are correct. So what is the total? Total of X bar. So total of X bar is this one, 2345.75. So that should be divided by number of sample. Sorry. So that is divided total 2345.75 divided by 10. Our sample size is 10. Therefore, the average is 234.57. 234.57. So I am rounding that to 2 decimals. Right. Then we have to calculate the upper control limit. Upper control limit we can calculate using this formula. Upper control limit. And the lower control limit also, I will give you the formula. Lower control limit. This is the formula. A2 value also will be given to you. A2 is 0.73. A2 value is 0.73. A2 is 0.73. Right, your answers are correct. So quickly we will do those things. This is equal to X double bar that we have calculated 234.58 plus A2 that is 0.73 into R bar. R bar we already calculated the average of the ranges, that is 19.6. Therefore the answer is 234.58 plus 0.73 into 19.6. 248.89. That is the upper control limit. Then the lower control limit is same formula, but you have to deduct it, right? Minus. So that means 220.27. So check, I will check your answers. Yeah, correct. So now we know the central line, we know the upper control limit, we know the lower control limit. So now our next step is we have to now draw the X bar chart. So X bar chart, same thing, but now this is diameter average, right? Diameter average X bar. So there we have to change these numbers because the range is 234. 234 and 220. So you will start from say like 200 or something. You will start from 200, then you have to the maximum maybe 248, 250, right? So 10, 20, 30, no, not enough. 5, 10. So like we're here 260. Then here 240, then here 220. So likewise, anyhow, you have to get a reasonable measurement for diameter x bar. Then you have to plot the points in the x bar chart. So it is difficult for me to put chart here. So I will develop. So now I am going to develop x bar chart using the mean values. So these yellow color values you have to use for x bar chart. So I am developing an x bar chart. Right. This is the bar chart. Okay. So these red color dots are the 10 samples. Average of those 10 samples. So this is the x bar chart. Now we are going to draw the control limits. Central line and control limits. So central line, that is 235. So this is the central line. Sorry. Central line. I will put in purple color. So this is the central line. So then we have to draw the upper control limit, that is 249. Upper control limit is 249. Upper control limit 249. Then we have to draw the lower control limit. Lower control limit is 220. Lower control limit is 220. So this is the X bar chart for our observations. So now tell me, now you know the tolerable area, you know the intolerable area. So now you have to tell me whether process is under control or not. Yes or no? Whether process is under control or not. Maybe difficult for you to tell me, but based on this graph, see, this is the central line, middle line, and all the points are within the limit, but one point is out of the limit. What is the point number? Sample number?
7, 9.
Yes. This one. Sample number 9 is out of the limit. So that means what? That this particular bar chart says process average is out of the control, right? As per the previous bar chart, that is range bar chart, that says okay, that was under the control. So the process variability was under control, but process average, the average size, there's a problem. One particular observation is out of the limit means we have to find out the reasons. If this is inside, no problem, but this is outside, no, therefore there's a problem. So you have to report that. So there are no variations in process variability, but there is a variation in process average. This is your final decision to the management. Variability is okay, but average, there's a problem. So what they have to find out? They have to find out the reasons. Okay. They have to find the reasons for this problem. Why average is different, right? So this is the idea of these charts. This is the idea behind these control charts. So now you know the benefits of control chart. By drawing the control chart, you can simply find out whether you are under control or not. Your process is under control or not. So again, I want to tell you two things. There are two types of variations. One is common variation, common cause. You don't need to worry about this. These variations, so you can see here, if you see, there are some variations, right? So 1, 2, there are small variation between these data points. These are the variation areas. So these variations are not a problem because they are common variations. You don't know the reasons. It occurs. But there is a problem with this because that is also variation, but above the limit. So that is maybe because machine problem or human errors or climate changes. That reason you have to find out immediately. Okay, and we studied two different charts. This is X bar chart, and also we studied this which one, range bar chart also we have studied. So that also studied. As per the range bar chart, no problem. There is no problem in the variation. Variation is under control, but average is there's a problem. That is what we study, and it is recommended to test the average, to test the R bar chart first, and then to test the X bar chart. So I hope now you have understood everything.